Today's topic is separable differential equations. I think you guys will like this one. It's pretty straightforward. A differential equation is an equation that has one or more derivatives in it. So it's something that's already got a dy dx or a prime, or in other words, or sometimes a double prime, or a double prime with a prime. No, I don't. That sounds fishy. I'd have to think more, but we'll see. Maybe one will show up. So we've got what's called a first order differential equation. So that means that we only took the derivative once. F prime is another first order. H double prime is a second order and third order, and you could go on from there. So we're talking about general solutions again. Remember, general solutions have the plus C. And then the particular solution is what they have to give us an initial condition. You can't find a particular solution unless they give you a hint. And then we go and find out what C is. So the separable differential equation, our goal is to get all the x's and dx on one side separated from all the y's and dy's. Once we get that set up, then we could obviously, what would we do to anti-derive or to get back to the original function? We would integrate both sides. Okay, so separating is not always easy. Today's stuff is this, at least this section, the first couple examples are pretty easy. Now look, for these type of problems, it is very, very, very important to show the separation of variables. So show the separation of the variables. So that's a point in and of itself. So usually it's 1 point for showing your work. 1 point for showing that you separated properly, and then another point for getting the actual answer. Well, depends on what the question is. 1 point for getting the general solution, then sometimes 1 point for getting the particular solution. Okay, so the graph of several solutions to the differential equation dy dx equals x squared over y squared is shown. So this is the graph. This is the graph of all the plus c's that you could get. So in other words, if you took one of these, you decided to highlight one of these and took its derivative, you would get this equation. Okay, so you would get this derivative. So these are possible solutions. That's why there's so many different ones, because depending on what C is, you're going to get a different curve that would turn out to give you still. All these curves have what as their derivative? X squared over y squared. Does that make sense? Hopefully that makes sense. So we're going to get into something called slope fields next. Like next unit section, yeah, all right. So this is just a small sampling of all the graphs. I'm predicting that there would be more. I think he just chose to show these 7. All right, so solve the equation and then find these particular solutions. So what we have to do first is we have to solve it. So my equation is dy dx equals x squared over y squared. Now, if I wanted to get y, that's my goal, is to get y by itself, get f of x, whatever you want to write it as. I would integrate, right? Well, do you know how to integrate something that has x and y on the same side? No. So that's why we have to separate first. So this separation is 1 point. So what would it take to move this over there? I would multiply by y squared, and I would get y squared dy. And then I would multiply this side by dx. And now all of a sudden I've got my variables contained on opposite sides, and so I can now integrate. This is something that I'm talking about. This is what you want to show. You have to show that step. You can't just jump to the next step. They want us to actually see that piece. So what would you do now? Now I can integrate both sides. So I'm going to integrate. I'm going to integrate. What's the integral of y squared, y cubed over 3 plus some constant equals, what's the integral of x squared? Would be x cubed over 3 plus some constant. I can't use the same letter because, they're different constants probably. Now, when I try to solve this thing, remember our goal is to get y by itself. So I want to have my solution to solve the equation looks like y equals or f of x equals. So I need to get some stuff. Now, when I move this constant over, it's going to combine with this constant. It's just going to become a new constant. So I would have y cubed over 3 equals x cubed over 3 plus, I'm going to use c again. Now, I think it's okay to not write this one here. I wanted to write it once just to kind of show you, but if you don't want to write it there, I think that's probably okay. Maybe you should write it. I don't know. I'm not going to agree. In this class, I'm not going to write it. Maybe on the AP test, you should write it twice. Okay, let's start solving. So I would, what farthest away from y on the same side is 3. So I would times everything by 3. Y cubed equals x cubed. What's c times 3? I don't know, some 3c, right? Which is some other constant. So I can just keep writing that thing as constant. And then who's keeping y from being by himself? Cubed. So what kills cubed is a cube root. Now, do you need plus or minus? You do not. We are cube rooting. Cube roots, if they're positive, come out positive. If they're negative, come out negative. This is what we call the general solution. That's general because we don't have a value for c yet. Okay, now that we've got the general solution, depending on the particular solution, we could then go get the actual answer with that initial condition. So let's take a look at part A. This is when y of 0 equals 2. So if this is my general solution, I can go ahead and start to plug and chug some things. So y equals 2, x equals 0, plus c. Our goal is to figure out what c is, so I'm going to do a lot of this in my head. What's 0 cubed? 0. 0 plus c is c. So I've got right now 2 equals the, I'll write it out. The next ones I'm not going to. 2 equals the cube root of c. Who's keeping c from being by himself? Cube root. What kills a cube root is a cube. So we get 8 equals c. Therefore, with the initial condition y of 0 equals 2, our equation, our particular solution, would be x cubed plus 8 getting cube rooted. Oh boy, I don't really like the way I drew that, but we're going to have to live with it. All right, so now let's kind of tie this into this, this graph over here. What was our initial condition? That our function had a y value, had an x value of 0 and a y value of 2. Well, if I go over here to the x value of 0 and track up to the y value of 2, that means this particular solution has the initial condition of y of 0 equals 2. And watch what happens. I'm going to graph this thing. I'm going to actually graph this function on my calc. There's a couple different ways. I'm going to use to the 1/3. I don't feel like going find the cube root button. X to the third plus 8 to the 1/3. That's the same as the cube root, right? My window, I'm going to adjust the window to the same window he has on his little window, his little graph here. Look what happens. Ba-boom. Does that look like the one that we highlighted? Pretty cool. Pretty cool. Now, depending on what your initial condition is, you're going to get a different graph every single time. Now, why does his look a little different than ours? Remember, this is a square and this isn't. If you ever want to square out your window so it looks exactly the same, you got to hit Y square or zoom square. And now it should look basically the same. Let me draw the line Y equals X just to see. That should slide right through there. Yep, looks just like it. Pretty cool, pretty cool. Okay, so now we've got to find a couple other particular solutions. We should play a game. I'm noticing as I make these videos how long it takes me to pick marker colors. Play a game. What color do you think he's going to use next? So y of 0 equals -2. I'm going to encourage you to pause here and try to find the particular solution. Actually, I want to write that before you pause. I want to write next to this that this is a particular solution. I like to kind of identify those as we go through. All right, pause. See if you can figure it out. It's going to be the same as this, except there's going to be a negative over here. I don't think I'm even going to show my work here. C is going to be equal to, so that's going to be a negative. When I cube a negative, it's going to come out to be negative. So C is going to be -8. Ugh, should I show my work? I mean, honestly, just put a negative here, and then when you cube a negative, you're going to get a negative. So no, I'm not going to show my work. So I get, therefore, my particular solution would be y equals x cubed minus 8 this time. So that would have been this curve here. If you want to grab your calc and try to sketch it, feel free, but I trust that it's going to work. And again, I want to write myself a little note here. This is called a particular solution. Well, that's called a general solution. And then lastly, we've got an initial condition of 0, 0. So y of 0 equals 0. I would encourage you to try to do it on your own. So let's see. So I'd go back here. Y is 0 equals 0 cubed plus c, getting cube rooted. Well, that's easy. 0, that's c's cubing 0. So I get c equals 0. And we get y equals x cubed plus 0. And let's clean that up a little bit. If I add the 0, who cares? When I cube root x, I get y equals x. This is a particular solution. And it fits with our picture up above again. If I have the initial condition of 0, 0, I get the line y equals x. Pretty cool. Pretty cool. Pretty cool. Okay. Find the general and particular solutions to the separable differential equation given the initial conditions, blah, blah, blah. I think you could do this on your own. If you want to pause and go for it, do it. All right, for those who need a little help, or if you're ready and already done it and you want to check your work, I need to first separate my equations. So I'm going to take, I like to write it out first so that they know where I'm working from. dy dx equals x squared y. So I need to bump the y over, which means I need to divide it, and then I need to bump the dx over, which means I need to multiply it. So when I divide by the y, you can put it under the dy. I think it's easier to write it as its own fraction because it's going to help you understand how you want to integrate. So from here, I've got this would be 1 point. Boom, on the AP test, there's 1 point. I now want to integrate. I'm going to write myself a little note for future references. One point on the AP test for what I wrote in blue. Now let's integrate it. What's the integral of 1 over y? Come on. Come on. Should know this one. It's a natural log of absolute y equals, what's the integral of x squared is x cubed over 3 plus c. So I just chose to throw my plus c on that one side. All right, let's talk about how to finish this off. Now this is going to take a little bit of work, so we need to get y by itself. So what kills natural log? Hopefully you said e to the. So now we get e to the x cubed over 3 plus c. And sometimes it's good to parenthesize that to show that that's all in your exponent. Now this is not a general solution at this point. This is not a general solution because we don't have y by itself. So there's going to be 2 options that we're going to go from for here. I'm going to show you both ways. You can decide which way you want to go going forward. But one turns out to be a lot of work at the beginning, but ends up being a lot nicer at the end. Okay, so option 1 is where I get rid of the absolute value, which means this thing could, okay, if I take this and I put it inside of an absolute value, how do I want to say it? What does an absolute value do to a positive? It leaves it positive. What does an absolute value do to a negative? Leaves it negative. Or sorry, leaves it positive. So what this thing here, I could put that in for y as a positive or a negative term. Y equals plus or minus e to the x cubed over 3 plus c. So think about that, right? This is what y equals. So if I took this thing and I put it in here, I would get, if this was positive e to the, I would get positive e to the. If I put a negative e to the in there, I would absolute value it and still get positive e to the. Option 2 is to take this thing and try to clean it up initially. So right now there's my y equals in option 1. In option 2, I'm going to try to clean this up, and it refers back to a move that we haven't done in a while, but hopefully you remember. So like e to the x plus y is equal to, see if you can finish that on your own. Hopefully you can remember. This is those exponent properties that we've done literally every year of your math career in high school. So a plus breaks into an add, e to the x times e to the y. I could never remember it with x's and y's in there. So what I used to do as a kid is I would put exponents on it, like e to the 2 times e to the 3 equals, it's my bad, I'm saying e, but I'm writing x, which equals x to the 5th. So that means I added them up. So I used to write out little examples to remind myself so that when I had to actually apply it, I could think through with easy numbers and apply it to something that has pretty complicated numbers. Anyway, so what I'm going to do here is I'm going to leave this as absolute value of y. So right now I don't have a plus or minus. I don't have to worry about that. And I'm going to take this, I'm going to make it e to the x cubed over 3 times e to the c. Right? That's the same property. I'm applying this property up here. I have e to something plus something else. That means I can separate them in e to the times e to the. Now you might say, why is this better? Well, it's actually a lot better because what's e to the c? This is some number. E to any number is some other number. So now I have absolute y equals some number times e to the x cubed over 3. Okay, now I'm going to get rid of the absolute values, which means I need to plus or minus this. Y equals plus or minus c e to the x cubed over 3. But what's c? Some constant. So we don't know if that constant is positive or negative at all. So this c can absorb this plus or minus, and I get y equals c times e to the x cubed over 3. Oh boy, which one's better? Which one's better? Well, my first gut is feeling like this is better. This is at least, I shouldn't say better, but this is what my brain would have done. And then I watched Corpy's video, and he went through it like this. And the payoff is going to be later on down the road. So I'm going to do part A using both options to show you that it doesn't really matter. One takes a little bit of work initially. One takes a little bit of work later on. So part A, that's f of 0 equals 1. So using option 1, I would have y is 1 equals plus or minus e to the quantity. Let's put 0 in there. Okay, I'm going to save myself some time. 0 cubed is 0 divided by 3 is 0 plus c is c. Okay, now our goal here is to get c by itself. So what would you do to both sides? Well, I'd have to natural log both sides. So when I natural log, I get natural log of 1 equals natural log of, and then I've got to separate these into their separate equations. Let's think about it this way. I probably should have separated that initially. So now I have two different equations. I have 1 equals e to the c, or I have 1 equals negative e to the c. Now in this case, I'm going to natural log both sides. So that would be the natural log of 1 equals the natural log of e to the c. What's the natural log of 1? What's the log of any base log of 1 is 0. You can think about this as e to the 0 is 1, so they would cancel out. But anyway, any log of 1 is 0. The natural log of the e to the cancel each other out, so I get c equals 0. Over here, when I try to natural log both sides, I get natural log of 1 equals natural log of e. Now we've got a problem. I cannot natural log a non-positive, so this would have no solution. So then c equals 0. So therefore my equation would become, remember I'm using option 1 here, y equals plus or minus e to the x cubed over 3, and then we said that c was 0. Now, yet again, I can't plug this in, so this is where this other one's going to come into play here, this last little caveat. I can't box this in yet, even though I plugged in C, because how many equations are here? These are 2 equations. So we're supposed to find the particular solution, which means we're supposed to find the one equation. So I have to take this now and look back at my initial condition to see which one of these would be true. So if I put 0 in for x, I would get 0. E to the 0 is 1, so I need to eliminate the negative case. So my equation would be y equals positive e to the x cubed over 3. Let's try to do this now using option. I'm going to leave a little note next to this problem. This was option 1. Now let's try this again, but do it with option 2. So f of 0 equals 1. My equation is absolute. My bad. My equation is y equals big C e to the x cubed over 3. Now I can plug in chug, so y was 1, c e to the 0. E to the 0 is what? 1. 1 times c, so therefore c equals 1, which then I plug back in and I get y equals e to the x cubed over 3. Same solution. Way faster. Option 2. Yeah, I didn't have to do any guessing and checking. That C absorbed the positiveness and negativeness within it, and so it took care of it all on its own. So all of this, I don't care which way you do it. My math voice would have never thought of doing what we did in purple. So option 2, I would have never thought to do. If you can remember and you want to try that, go for it. So I'm going to have you try part B. You can do part B either way you want. I'm going to try to squeeze both of them. Oh boy. I'm going to try to squeeze both of them in here. And maybe I'll do some up at the top. So pause and try to do part B on your own, whichever way you want. All right, let's see how you did. So part B is telling me that f of 0 is negative 2. I think this one's going to be smaller, so I'm going to do it this way first. I'm going to use option 2 here. So y is negative 2. Big C, I don't know, e to the 0. So c is negative 2. So then my equation would be y equals, remember this is option 2's equation. So that would be negative 2 e to the x cubed over 3. Now, I had to do all my legwork early here, but it was way quicker later on. So I'm going to leave 2 little notes. This was using option 2. And I should go back over here and write a little reminder that these are particular solutions. Sorry, these are general solutions. That's a general solution. This is another option for a general solution because they still have C in there. I think I could squeeze it up here. Let's try to do part B again, but we'll do it from the perspective of option 1. So part B, So I get f of 0 equals negative 2 again. So then I would put y as negative 2 plus or minus e to the 0. So that's c again. Actually, this one's not that bad because what does if this is positive, okay, and then I try to if I try to natural log this side right away, it's over, right? I can't natural log this, which means I have to accept this as being the negative version. So I know right away that I can eliminate the other option. It's got to be this, because if it was positive, I'd have a natural log of a negative. So when I solve, I divide both sides by a -1, so 2 equals e to the c. Natural log both sides, natural log of 2 equals c. Therefore, my y would be equal to, I can come back to this, we knew it had to be the -1, so I'm not going to take them both anymore. I'm going to take right away the -1, e to the x cubed over 3, and then we said c plus natural log of 2. I'm definitely going to parenthesize that mess. All right, now you're looking at this, and you're looking at this, and you're saying, wait, are these the same thing? Well, yeah, if you do a little bit of cleanup, they are. I'm going to just apply this, this property again of exponents. So I've got e to the two things added together, which means I can separate them. So this is negative e to the x cubed over 3 times e to the natural log of 2. What's e to the natural log going to do? That's going to turn this. They're going to cancel, so I'm going to have a 2 here. What's 2 times a negative? Negative 2 e to the x cubed over 3, which is the same equation. Now, you don't have to do that twice. I did it twice, but remember, this one we had to do a lot of work after. This one we had to do a lot of work at the beginning, but very little work after. So you decide. Like I said, my math voice, I would have never thought to do this. Okay, here's a great, this is from 1998. Mr. Stuckey was what would that be? I was probably on my first junior year. I didn't do real well at Michigan State. I failed a couple of years. And so that was my first junior year in 98. So 94, freshman year, 95. So 95 was the end of my freshman year. 96 was end of my sophomore. 97 was my first junior year. 98 was my second junior year. 99 was my first senior year. And then my only senior year. And then I had to student teach for a year. So there's my 6 years. So I was a junior at the time, not doing real good in school. That's when I started to get serious. Anyway, let this be my initial condition. Okay, so f is the function whose slope is given by this. So this is the equation for all the slopes, all right? Does that make sense? So they only gave me one condition, one initial condition. They only told me 1 point. This is the point 1 comma 4. F is all of these points, x and y, where the slope turns out to be this. So find the slope of the graph at the point where x equals 1. Well, wait. If they tell me x equals 1, and I look back at my slope formula, so I want to find the slope. Well, that's the slope. If I want to plug something into slope, I need x and I need y. So they only told me where x is 1. Oh, yeah. They gave me this as initial condition. So if x equals 1, y equals 4. I can just, and this is strictly plugging and a chugging, so we want to find the slope. The slope is equal to dy dx, which is equal to 3 times 1 squared plus 1 over 2 times 4. If this is a free response, you can stop here. You don't have to keep going, but we obviously want to keep going. You can tell down here, we're going to need that. So anyway, that's 1, that's 3, that's 4. 2 times 4 is 8. 4 over 8 is 1/2. Write an equation of the line tangent to the graph of f and use it to approximate f of 1.2. So let's do this in pieces. I'm going to encourage you to pause. This is old school, man. This is first semester. Write an equation of the line tangent to the graph at a point. We can do this. You don't need my help there. So pause, give it a try. So for some reason, am having a brain fart on Taylor form. So I'm going to use point slope, which is y minus y equals slope x minus x. Yeah, good. So there's my equation. Maybe you did Taylor. Taylor just means I move that 4 over to the other side. So this is the way I chose to write mine in. Slope intercept. Maybe you move the 4 over and had 4 plus. Great. Now we need to use this to approximate f of 1.2. So maybe actually I think I am going to rewrite this now. So therefore f of x is approximately 4 plus 1/2 times x minus 1, right? Because the tangent line, the curve is approximately what's happening at that tangent line. So now I want to see f of 1.2. This is an approximation. I should highlight that. I'm going to put that. I'll use this color. We want to approximate, which means you need some squiggles. Squiggle alert. So f of 2 is approximately this. So that'd be 4 plus 1/2 times the quantity, 1.2 minus 1. Let me try to get rid of that parenthesis. I don't like that one there. Which then equals, why did that turn into an equal? Because whatever this is going to be equal to whatever. This is not an approximation from here to here. This is an approximation to here, but this actually equals whatever this is. So I'm going to go 4 plus 1/2 times 1.2 minus 1 is 0.2. Yeah, we can do this in our head. Half of 0.2 is 0.1. 0.1 plus 4 is 4.1. So if we wanted to write this up nicely, we'd write f of 1.2 is approximately 4.1. And our work, those are approximately, those are awful, but those are approximately symbols. Okay, we'll let that slide. Now find what the actual function is by taking our slope formula, our equation, our differential equation, and separating it so that we can actually solve it towards the initial condition of f of 1 equals 4. So that means I need to find the general solution first. So I'm going to encourage you to pause, try to find the general solution on your own. All right, let's see how you did. So I'm going to just separate this time. So I'm going to bump this across, so that would be 2y dy equals, I'm going to bump this over. This is an important detail. You would not get the point if you didn't parenthesize 3x squared plus 1. Because if you just write 3x squared plus 1 dx, it looks like the 1 and the dx are what's connected together. So anyway, that's 1 point if you write it properly. Now we want to integrate that bad boy. Integrate. So the integral of, so that would be 2y squared over 2 plus c1. That would be 3x cubed over 3 plus x plus c2. So y squared equals x cubed plus x plus, and I'm just going to call that big C. That is not a general solution yet because we don't have y by itself. So now I'm going to take this and I'm going to rewrite this up here. So y then is equal to plus or minus x cubed plus x plus c underneath a nice square root. This is a general solution. So we have to find the particular solution. So the particular solution is the situation where f of 1 equals 4. So I'm going to start plugging and a chugging. Let's go with a nice blue here. So now I'm going to try to find the particular solution. I might be able to fit it over here. So 4 equals plus or minus 1 cubed plus 1 plus c, getting square rooted. What would you do to both sides? Well, who's farthest? Actually, let's combine some stuff first. 4 equals plus or minus, that's 1 cubed, that's 2 plus c. Who's farthest away from c on the same side is the square root, so I'm going to square both sides. So 16 equals, and then what's a negative squared or a positive squared? No problem. Bump over the 2, we get 14 equals c. Now we have a situation. So if I go back over here and I rewrite this, I would get y equals plus or minus x cubed plus x plus 14. But this is not a particular solution because it has two actual equations there. So I want to make sure I pick which one actually makes sense for my initial condition. So if I put 1 in here, I get 1 cubed plus 1 plus 14. So that would be 16. The square root of 16, which one of these would I have to include to get an actual answer of 4? So the square root of 16 is 4. I want it to be the positive version. So I'm going to have f of x equals the positive x cubed plus x plus 14 underneath the square root. That is what we call that is the particular solution that we want. And I don't know if somewhere in here I'm supposed to write let y equals f. I always wonder about that kind of stuff. I don't know if they'd be that picky because you don't want to write f of x in all of these. So I wonder if you're supposed to at some point write something like, I don't know, let y equal f of x or something like that to show that they're the same. I don't know. If you do or don't in my class, I don't care. I don't think they'll matter on the AP test. Use your solution from part C to find the exact value. Now look, this is the actual function. This is what we approximated the function value to be, but this is the actual function. So now we can figure out what actually is happening at 1.2. This is not an approximation. So this would be 1.2 cubed plus 1.2 plus 14, getting square rooted, which equals, and I use my calc, 4.114. So don't think you had to do that in your head. Calc. How was our estimate? Pretty good. Actually, let's talk a little bit about what can you tell me now about the curve of f? So at this spot, what can you tell me about our estimate? Our estimate was an overestimate or an underestimate. So our estimate was 4.1. The actual value was 4.114. So wait a minute, let's rethink this again. So 4.2, the actual value was 4.114. The estimate was 4.1. So the estimate was an underestimate. So what kind of a curve must I have? This must be so f must be, okay, I always got to redraw this. So I've got either concave up or I've got concave down. So if I've got concave up, so concave up, and I draw a tangent line, that tangent line is always going to be an underestimate. If I've got concave down, and I draw a tangent line, see how those values are always higher than the values below them? So this is an overestimate. So f must be concave up. Let's see if that's true. Can we make a quick sketch? Let's make a quick sketch of our curve. So what is our function? The square root, the square root of something. So the square root graph looks something like this. Yeah, that fits, right? That fits. So So if I drew some tangent line, dang it, no it doesn't. What do I, oh, it's the square root of a cubed. I don't know what that graph looks like. I don't know what that looks like. It's x to the 2/3. I don't know what that looks like. Never mind. Sorry. F must be concave. Let's look. So we think F is a concave up graph. Let's see if things are going to blow up here on me or if things are going to be awesome. So I want to graph the square root of x to the 3rd plus x plus 14. Come on, math. Don't let me down. Yeah, it's concave down. Oh, dang it. I'm going to do a zoom fit. Look what we're looking at, what's happening around 1. I'm going to trace to 1.2. Shazam. What is F at 1.2? Concave up. Oh, gosh, thank goodness. Thank goodness. What would the solution equation be if the initial condition were f of 1 equals 4? Let's go back up here. So if f of 1 equals 4, that means f of 1 equals negative 4. So my slope would be negative. I'm not going to go through all that again. what would be what they want us to do here? So this would be negative 4. Everything would be opposite, wouldn't it? Because my slope would be negative. This would be a negative 4. So if my initial condition was negative 4, what would that change here? Oh, yeah. So this would be negative 4. I don't need to go all the way back. I was going all the way back and kind of freaking out. But if I put negative 4 in here and I square it, I still get 16, and I still get C equals to be 14. But when I did my check here, if I need this thing, I would need this thing to equal negative 4, which means the negative case would be the good case. So we don't have to go all the way back. Let's just f of x would equal x cubed plus x plus 14, except this time the root would be negative. All right, so if you feel like this is a lot, I would encourage you to pause, or I'm going to make you pause because I'm going to stop the video, but start to attack the homework and don't wait until the very end. After you get all the notes done, usually the homework is a little bit overwhelming. So good luck.